For thousands of years, human beings understood the world through stories, tradition, and inherited beliefs. People explained lightning as the anger of gods, illness as a curse.
Fires of the earth reached up to the heavens, and there, etched in flame, were the symbols of the forgotten gods.
The stars as symbols rather than worlds. These explanations gave comfort, but they did not reveal truth. For centuries, humanity lived inside a worldview shaped more by imagination than by investigation. But beginning in the 1500s, something began to shift, quietly at first, then with unstoppable force. A small group of thinkers dared to challenge what everyone else accepted. They chose observation over obedience, measurement over myth, and experiment over tradition. This change did not just rewrite books, it rewrote the human mind. This moment is what we now call the scientific revolution, a transformation that reshaped everything we know about the universe and ultimately ourselves. Before the scientific revolution, European knowledge was dominated by ancient Greek ideas, especially those of Aristotle and Ptolemy. Aristotle believed that objects fell because they sought their natural place. Ptolemy imagined the Earth sitting perfectly still at the center of the universe, with planets and stars moving in perfect circles around it. These ideas were taught for over 1,000 years without being questioned. To challenge them was to risk being seen as foolish or dangerous. Knowledge was something to memorize, not something to test. Humanity respected knowledge, but did not interrogate it. This world began to change with a man named Nicholas Copernicus. Working alone, far from universities or great cities, Copernicus studied the heavens with nothing more than mathematics and patience. After decades of observation, he proposed something revolutionary. The Earth is not the center of the universe. The sun is. This idea shook the foundations of European belief. If the Earth moved through space, then the heavens were not perfect spheres. If the heavens were not perfect, then perhaps the universe was not built around humans at all. It was the first crack in an ancient worldview. A century later, Galileo Galilei turned the crack into an opening. With a simple telescope, an instrument still crude and imperfect, Galileo looked at the moon and found not a smooth divine surface, but mountains, craters, and shadows. He discovered moons orbiting Jupiter, proving that Earth was not the only center of motion. He watched the phases of Venus, confirming that Ptolemy's model was wrong. Galileo didn't merely observe, he experimented. He rolled iron balls down inclined planes, timed with water clocks, discovering that falling objects follow mathematical laws. He proved that knowledge is not what tradition tells us. Knowledge is what the world shows us. At nearly the same time, Johannes Kepler refined the cosmic structure even further. Using decades of precise data collected by Tycho Brahe, Kepler discovered that planets do not move in perfect circles, but in ellipses. This was a radical idea. For centuries, circles were believed to be the only perfect shape worthy of the heavens. Kepler's discovery meant the universe followed geometry, not mythology. He revealed that celestial motion obeys rules, not divine perfection. Then came Isaac Newton, a mind so powerful that his ideas still shape all of modern science. Newton realized that the same force that pulls an apple toward the ground is the same force that guides the moon around the Earth and the planets around the sun. He unified the heavens and the Earth with one law: gravity. He developed calculus, built theories of motion, and wrote Principia, one of the most influential books ever published. For the first time in history, humans could describe the universe with equations: precise, predictive, universal. But the scientific revolution was not just about astronomy and physics. It transformed every corner of human understanding. In medicine, William Harvey demonstrated that blood circulates through the body, overturning centuries of mistaken beliefs from ancient authorities. In biology, early microscopes revealed bacteria, cells, and entire ecosystems invisible to the naked eye. In chemistry, the shift from alchemy to controlled experimentation allowed scientists to identify elements and reactions. In meteorology, barometers and thermometers transformed weather from superstition to measurement. Every new tool extended human senses, allowing us to see what was previously unimaginable. But the most powerful invention of all was not a device. It was a method, the scientific method. Observe carefully, measure precisely, test repeatedly, question fearlessly, accept nothing without evidence. This method became the foundation of modern science, education, and technology. The scientific revolution reshaped society as well. It encouraged doubt, debate, and intellectual independence. It inspired Enlightenment thinkers who argued for individual rights, democracy, and human dignity. It influenced political revolutions, economic systems, and industrial progress. It created the very idea that knowledge should be open, testable, and shared. This revolution was not loud. It did not happen through battles, kings, or empires. It happened slowly, quietly, in observatories, in letters between scholars, in secret experiments conducted late at night. Its weapons were telescopes, thermometers, mathematical diagrams, and careful notes. And yet, its impact is all around us. In electricity, medicine, transportation, communication, engineering, computers, satellites, vaccines, and modern life itself. We live inside the world the scientific revolution created. A world where truth is not declared, it is discovered. A world where progress is not luck, it is built. The scientific revolution was more than a moment in history. It was a transformation of the human mind, a shift from believing to knowing, from tradition to reason, from myth to measurement. And that shift is the foundation of the modern world.